Good morning students. Thank you very much students for clicking on my video. I am your Nagini ma'am, chemistry mentor. In today's section, I am giving the excellent trick to find the products formed at the electrodes in electrolysis process students. This topic is from electrochemistry lesson 2nd PUC. Here students are facing the problem in this area. Here at anode, at cathode, what are the gases released? What are the products are formed at anode and cathode? So they're asking the different types of solutions students, aqueous solutions, molten solutions. Okay now, so aqueous NaCl, in the case of molten NaCl, in the case of aqueous NaCl, what type of elements are deposited at the cathode and the anode, what type of products are formed at the anode and cathode. They're asking the questions in the competitive exam students. In this area their students are facing the problem here. In the case of aqueous NaCl, which gas is liberated at the anode? In the case of aqueous NaCl, which gas is liberated at the anode? So like that, here different types of questions are asking students. So in this section, I am giving the excellent trick to find the products which are formed at the electrodes in the electrolysis. Okay, now you can easily answer the in this video students. You will get the clear idea on this topic. Okay, and next we will discuss the previous year's questions also, then you can easily solve the questions students. Okay namma. Now see students, in this case first I am discussing the electrolysis. What is the electrolysis? Now I am giving the definition students. What is an electrolysis? Electrolysis. What is electrolysis students? It is the process in which on passing electricity on passing electricity electrolyte splits into ions. The electrolyte splits into ions. Okay, splits into ions and deposited at the opposite electrodes. Ions, and these ions are deposited at the opposite electrodes. At the opposite electrodes. Clear students? Electrodes, it is nothing but electrolysis. What is electrolysis students? It is the process in which on passing electricity the electrolyte splits into ions and deposited at the opposite electrodes. Now see students, here this is the electrolysis process is taking place. Now here I am taking the molten NaCl solution. These two are the electrodes. One is acting as anode, another one is acting as a cathode students. Are you following? Anode and cathode. Here anode charge is which one students? Anode charge is positive charge. This is positive. Cathode charge is negative charge. Are you following? So this is positive, this is negative. Now we know that in the NaCl solution, molten NaCl, what is nothing but molten students? It is in the melting form. That means melted NaCl solution will be there. So that means it is in the liquid form. Are you following? So molten state or fused state, both are same nana. Okay, or what we will call fused state. Understanding? Fused state, molten state or fused state, both are same. That means here there is no water content, only NaCl. It is in the liquid form. Are you following? So already we know that the difference between the aqueous NaCl and molten NaCl, by the addition of water, aqueous NaCl means addition of water to the compound, then we will get the aqueous NaCl. Are you following? So by the addition of water to the compound, suppose NaCl salt is there, so by the addition of water, what we will get? NaCl is dissolved in water, we will get the NaCl solution. That is calling as aqueous NaCl solution. If without addition of water, without addition of water, students. Suppose NaCl, by heating it, if suppose it is melting, are you following? In the absence of water, by heating the NaCl salt, it is converted into liquid state. So that form is calling as molten state or fused state. Clear this one? So in the molten state, it is in the liquid form, it is not having any water content. Okay, now in NaCl is deposited into first, it is dissociates into, students, NaCl, it dissociates into Na plus and Cl minus ions. Correct, Amma? Na plus and Cl minus ions. One cation, one anion. We know that cations, whenever here electricity is passed, students, through the electrodes. Okay, electrolyte, whenever electric current is passed. What is electrolysis? It is a process in which on passing electricity. So whenever electricity is passed, the electrolyte splits into ions. Now this electrolyte is there now. So this is the molten NaCl. This is the electrolyte, students. What is this one? Electrolyte solution. Clear this one? That means the substance which splits into ions by passing electric current, that is calling as electrolyte. So this is the electrolyte, students. We are taking molten NaCl. This is the electrolyte. Now this electrolyte, by passing electricity, it is splits into ions. Now NaCl is split into ions, Na plus and Cl minus ion, and these ions are deposited at the opposite electrodes. That means this is the cation, this is the anion. Cations are deposited at the cathode, chloride anions are deposited at the anode. We know that cations moves towards cathode, correct or not? So in these ions, what ions will be there? Na plus Cl minus ions will be there. Now these cations moves towards the cathode, students. These ions are moves towards the cathode, and Cl minus ions, anions, these ions are moves towards the anode, students. Are you following? So cations moves towards cathode, anions moves towards anode. Are you understanding? Clear this one? So cations moves towards cathode, anions moves towards anode. Are you understanding, students? Anode. Okay, now listen, students, this is the process of electrolysis. Understanding? Now in the case of molten NaCl, so what are the products liberated at the anode and cathode is asking the question. We know that at anode oxidation reaction taking place, at cathode reduction reaction takes place, students. Yes or not? Now see, Nana, here what reaction taking place at anode? Which reaction? Oxidation reaction takes place, correct? At anode, oxidation reaction takes place. Clear this one? Oxidation reaction takes place. At cathode, which reaction takes place, students? Reduction reaction takes place. Reduction reaction takes place. Oxidation is nothing but loss of electrons. Reduction is nothing but gain of electrons. Clear this one? Now I am taking the molten NaCl. Suppose NaCl solution, molten NaCl solution is there, electrolyte solution. So what are the products obtained at the anode and cathode? These two electrodes are inert electrodes, students. For example, platinum electrodes. Inert electrodes we are taking. Platinum electrode, we know that. Okay. So that means the electrodes which are not participating in the chemical reaction, those are called inert electrodes. Okay. Now see, students, in the molten NaCl case, in the case of molten or fused state, here in two cases I am going to discuss, students. First case one, I am going to discuss in the case one only about the molten state of compounds, molten state of electrolytes. In the second case, I want to discuss about the aqueous electrolytes. Are you clear? Okay. Now in the first case 1, I am going to discuss about the molten state. Now see, Nana, case 1. In case 1, I am going to discuss about molten electrolytes. Okay, molten electrolytes. So they are having only one cation. They have how many cations, students? One cation, one anion they have, correct? One cation, one anion they have. Okay, remember this. Okay, molten electrolytes. So here NaCl I am taking. Now in this NaCl, students, see here, this is the first case. First case NaCl. So in NaCl, sodium chloride, molten NaCl, I am taking molten NaCl. Okay. Now here, which is it is sodium is the cation, chlorine is the anion. We know that. Now sodium is cations. Now it is moving towards the cathode. Correct or not? So cation. It is moving towards the cathode, students, and chlorine moving towards anode. Correct or not? This is anion. Anions are moves towards anode. Sodium cation, it is moves towards the cathode. Are you following? It is splits into ions, Na plus and Cl minus ion. So Na plus ions, are you understanding? So Na plus ions are moves towards the cathode and Cl minus ions are moves towards the anode, students. Here which ions moves towards Na plus, here which ions? So Cl minus ions. Okay, we know that at cathode which reaction is taking place? Reduction reaction taking place. So that's why reduction is nothing but what, students? Reduction is nothing but gain of electron. So by gain of one electron it becomes sodium. That means sodium is deposited. This is which reaction, students? Reduction reaction taking place at where? Cathode. Okay, now this is at the cathode, students. Are you following? This is at the cathode. Na plus ion deposited at the Na plus ions moves towards the cathode. Now these Na plus ions at cathode, which reaction taking place? Reduction. So that's a Na plus ion by gain of one electron it becomes sodium. That means which product is deposited at the cathode, students? Sodium. So answer is sodium, students. Sodium is deposited. So it is deposited at the cathode. Clear this one? It is deposited at the cathode, students. Okay, number. This is at the cathode. But what about anode, students? At anode, now we know that at anode which reaction taking place? Oxidation. Oxidation is nothing but loss of electrons. Correct? Now the Cl minus ion undergoes oxidation. By loss of electrons, by loss of one electron it becomes half Cl2. That means it becomes Cl2. Cl minus kada. So that's why to to balance the charge, here I am taking one electron. It lost one electron. Then it becomes one chlorine atom. Here one chlorine atom there. To balance that one I am taking, but chlorine it is in the molecular state. It is existing. It is stable. So that's why Cl2 I am taking. Here half Cl2. Cl2 means two chlorine atoms. But here left hand side only one chlorine atom is there. That's why I am taking here half moles. Okay, now two chlorines, half means one chlorine atom. Clear? So which gas is liberated? Which gas is produced at the anode, students? Chlorine is liberated. Are you following? Cl2 gas is liberated. It is liberated at the anode. Clear this, students? So this is the answer. So in the case of molten NaCl, what are the products obtained at the anode and cathode? Okay, understanding? So this one is suppose molten NaCl is electrolyzed. Are you following? So molten NaCl is electrolyzed. Then what are the products? Electrolyzed. What are the products obtained at the cathode and anode? So understanding question, what are the products? What are the products at cathode and cathode and anode? This is the question, students. Clear this one? So what are the products, students? At cathode sodium, at anode chlorine. Are you clear? So this is one example. It is a case one, molten state. I am discussing about only here molten state. Are you following? Case one is completely belongs to molten state, molten electrolytes. Okay, number molten electrolytes. This is first example, students. Okay, now first example, molten NaCl. Now I am taking the molten. See, students. Second example. See here, second example, students. Second one. Molten NaBr. Molten NaBr. Now in this case, molten NaBr, students, NaBr. Okay, if suppose molten NaBr is electrolyzed, then what are the products obtained at the electrodes at anode and cathode? So we know that in the sodium bromide, first one is cation, this is anion. So cations are most towards which one, students? Towards cathode side, and anions are most towards the anode side. Are you following? So anions are moving towards the anode. So what is cathode, students? Here first of all, it is dissociates into NaBr, dissociates into Na plus and Br minus. So which ions are passed towards the cathode, students? That is Na plus ions. Here anode side, which ions are passing towards the cathode? Br minus ions. Are you following? So these ions are passing towards the cathode and anode. Okay, now see, students, here now Na plus ions, cathode, at cathode what reaction taking place, students? Reduction reaction taking place. So reduction is nothing but gain of electrons. Are you following? Nothing but gain of electrons. Okay, here which reaction taking place? Oxidation is nothing but loss of electrons. Are you clear, students? Loss of electrons taking place. Okay, now see, Nana, here reduction. That means here Na plus ions are undergoes which reaction, students? Na plus ions are Na plus ions undergoes reduction. So that means Na plus ions by gain of one electron. So gain of electrons becomes sodium. That means sodium deposited at the cathode, and oxidation bromide kada. So Br minus by loss of electron, it becomes half Br2. Clear? Bromine also it is in the form of Br2, it is stable. So that's why Br2 we are taking. So which is the product, students? Here Br2. So Br2 is liberated at the anode. Are you following? So this sodium is liberated at the cathode, students. Are you following? So like this you have to find an understanding in case of molten electrolytes. Now I am going to explaining in the case of aqueous electrolytes. Okay, the aqueous state of aqueous electrolytes, what about the what are the products obtained at the cathode and anode in the electrolysis process? So in the first molten state, students, how many cations and anions will be there? I told you one cation and one anion is present. Correct or not? Now in this second case, students, here I am taking in second case what I am discussing, case 2. What is the case 2, students? Aqueous electrolytes. Aqueous electrolytes. I am taking aqueous. Okay, now these aqueous electrolytes containing, students, aqueous is nothing but water. Okay, now by the addition of water, okay, now that compounds becoming solutions. That means aqueous NaCl is nothing but NaCl is dissolved in water. It is in the liquid form. Okay, aqueous electrolytes. In case of aqueous electrolytes, students, here how many will be there, students? Two cations. So two anions will be there, students, in the case of aqueous electrolytes. Understanding? For example, I am taking aqueous NaCl I am taking. Okay, aqueous NaCl. That means in aqueous means NaCl means here which is dissociates into Na plus and Cl minus, one cation, one anion. Aqueous is nothing but water. So it is dissociates into H plus and OH minus ion. So that's why here how many cations are there, students, in the aqueous electrolyte solution? Two cations. So and two anions are there. Are you following? Two cations and two anions are present. Understanding, students? Two cations, two anions. Okay, now in this case, now here before that only one cation, one anion. So that's why at the one is undergoing oxidation reduction. So like that which is formed we can easily understand, we can easily identify. But in this case, students, two cations, two anions are there. Now here how to identify? Now you have to remember, here I am giving the excellent trick, students. Here which product is formed at the anode and cathode, I'm giving the best trick, excellent trick, students. Listen carefully. So first of all, at cathode, okay now, so first of all, product obtained at the cathode. First case, here product at the cathode. Okay, product at the cathode, and here product at the anode. Now see students, product at the cathode, product at the anode. Now I'm divided into two parts students. Product at the cathode, first I'm going to discuss. Here I'm discussing the 2 points students. In the first point, what I'm saying, reduction potential of water. First point, reduction potential of water if it is greater than reduction potential of cations, reduction potentials of, okay, reduction potential of cations. Which cations? So first group, second group and 13th group, first, second and 13th group elements, or we will call it as third A group also. So 13th group elements. Are you following? 13th group elements. Clear this one? So 13th group elements. Now see students, first group elements means lithium, sodium, potassium, rubidium, cesium, francium. And second group elements, what will be there students? Calcium, strontium, barium, radium. These are the second year group elements. 13th group elements means what elements will be there students? Aluminium, silicon, germanium, gallium, indium, thallium. These are the 13th group elements students. Okay, now we can take the examples. First year group elements, some elements, sodium. Okay, now sodium, potassium, first year group, Na plus, K plus, and second year group I am taking Ca plus 2, Mg plus 2, and 13th group, okay, 13th group elements, which one students? Aluminium plus 3, Al plus 3. Okay, suppose these metals are there. Okay, now what I am saying, we know that at cathode which reaction taking place? Reduction kada. So that's why here the potential will call it as reduction potential. Are you following? This here what is taking place? Oxidation, correct? Here at anode oxidation takes place. That's why its potential is calling as oxidation potential, correct or not? Here energy is released or gained. Here also energy is released or gained. According to that we'll call it as reduction potential, and this is calling as oxidation potential. Now see Nana, here reduction potential of water if it is greater than reduction potential of cations, first, second, 13th group elements. Then what is the trick students here? The reduction of water, that means water undergoes reduction at the cathode. So what is the main point you have to understand? Water, so water undergoes, that means water reduction potential is more than these metal ions. So that's why water undergoes reduction. Water undergoes reduction students. Reduction at the cathode. Undergoes reduction at cathode. Clear this one, at cathode. So water, in this water, it dissociates into what students? H plus and OH minus ions. So that means H plus undergoes reduction at the cathode. Whenever H plus ion undergoes reduction, okay, now that means by gain of electrons it becomes half H2. Clear this one, half H2. So that means here electron charge is balanced, one hydrogen atom, half H2. That means H2 gas is released. So that means what we can say? H2 gas is released at the cathode. Clear this students? So this is the trick you have to remember. Understanding? So this is the trick you have to remember students. Clear this one? So this point you have to remember. Okay, so if the reduction potential of water is greater than these metal ions reduction potentials, then water only undergoes reduction at the cathode. In water, if it is dissociates H plus and OH minus kada, that means it is cation, it is anion. Cations moves towards the cathode, anions moves towards the anode, so that means cations undergoes reduction. That means by gain of electrons it produces H2 gas. So H2 gas is released at the cathode. Are you following? Now I am giving the second trick students here, second point. Now see Nana, second point, second one, if the reduction potential of water, if it is less than reduction potentials of cation, that means reduction potential of water. Suppose I am taking the reduction potentials of water, students. Here water reduction potentials, if it is less than reduction potentials of other cations, means what, students? If it is less than other cations means what, students? That means except one, say, first group, second group, and 13th group. Are you following? So reduction potential of water, if it is less than other cations, so then what you have to do? Other cations means what, students? Of other cations, reduction potentials of other cations means except first, second, and 13th group elements. Means what, we can take example, students. Here Cu plus 2, Ag plus, okay na, gold Au plus 3, and cadmium. Are you clear? Cd plus 2, and next we can take zinc, Zn plus 2. Are you following? So if the reduction potential of water is less than these metal ions, then these metal ions undergoes reduction. That means water does not undergo reduction, students. Are you following? So here what you have to remember, students? Water does not undergo reduction. Clear this one? Water does not undergo reduction, students. Clear this? Does not undergo reduction. That means these metals are undergoes reduction. That means if copper ion undergoes reduction, copper metal is deposited. Silver undergoes silver metal is deposited. Au, gold is undergoes reduction. Gold is only Au is deposited. Cadmium undergoes what is deposited? Copper. Silver, if it undergoes, what is deposited at the cathode? Silver. Gold means gold. And Cd, zinc, if you take zinc. Are you understanding? So that means these are undergone. Just one example, see, students. Copper, if I am taking copper, Cu plus 2, it undergoes reduction. That means what, students? By gain of 2 electrons, it becomes copper. That means copper is deposited at the cathode. Are you following? So that's why silver deposited at the silver. Au plus 3 take means if it is undergoing reduction, Au is deposited at the cathode, like this. Nana. Now see, students, product at the anode. Now I am taking at the anode. What is the anode, students? Here oxidation potential you have to see. If the oxidation potential of water, now see, students, what is the first point? Oxidation potential of, okay, now see, Nana, oxidation potential of water, if it is greater than, water is greater than, students, F minus, okay, F minus some ions, SO3 minus sulfite ion minus 2, SO4 minus 2, nitrate ion, NO3 minus, thiosulfate, S2O3 2 minus, etc. Now these ions are there, anions. Are you following? If the oxidation potential of water is greater than these oxidation potentials of ions, students, anions, then water only undergoes oxidation at anode. That means water undergoes, so here what you have to remember, students? Water undergoes oxidation. So here what is the trick, students? Water undergoes oxidation. Clear, students? Here water undergoes oxidation and releases which gas, students? O2 gas. Clear this one? Undergoes oxidation, releases O2 gas. Because we know that water dissociates into H plus and OH minus ion. So this is the cation. This is the cation, OH minus ion. This H plus is the cation. This is OH minus ion is anion. Now anions are moves towards anode kada. So these are moving towards anode. Are you following? Moving towards anode, students. And here anode. Now this water undergoes, okay, now this water undergoes oxidation. Are you clear? So whenever water undergoes oxidation, students, here what is the reaction taking place? Here I am taking the 2 moles of water. Here produces 4H plus 4 electrons plus O2 gas is released. That means oxygen gas is released, students. Are you following? So that means water undergoes oxidation. This point you have to remember, students. Are you following? Only water undergoes oxidation. Okay, now see, students, second point. What is the second point? Oxidation potential of, now see, students, oxidation potential of water, if it is less than, except this ion, students. So that means what we can take, students, here Cl minus, Br minus, F minus, etc. Oxidation potentials of these one. Are you following? So these are also oxidation potentials of F minus, sulfate ion, sulfide to sulfate to nitrate, thiosulfate. So like that, here oxidation potentials of these ions are there. Then water does not undergoes oxidation reaction, students. Understanding? So water does not undergo oxidation. That means which are undergoing oxidation? These ions are undergoing oxidation. Okay, so water does not undergoes oxidation. Clear, Nana? Does not undergo oxidation. Which are undergoing oxidation? Cl minus, Br minus, F minus undergoes oxidation, students. Are you following? Undergoes oxidation. That means chlorine releases Cl2, Br minus releases bromine, F minus releases F2 at anode. Are you following? So this trick you have to remember, students. Okay, then you can easily understand. Are you clear this one? So other than, see here, water does not undergoes oxidation, students. Okay, see, only these ions undergoes oxidation. That means if Cl minus undergoes oxidation, what is the reaction, students? Actually, one example, Cl minus undergoes oxidation, it produces half Cl2 by loss of 1 electron. Okay, that means chlorine gas is deposited at the anode. Like that, Br minus, Br2, F minus, F2, students. Okay, Namma. So reduction potential of water, if it is less than reduction potentials of other cations, water does not undergoes reduction. These are undergoing reduction. So the metal only deposited at the cathode. Are you following? So this you have to remember. Okay, Namma. Understood, students? Now I'm discussing the aqueous state. Case 2 question, students. See here, aqueous electrolytes I'm discussing. 2 cations, 2 anions are there. Okay, Namma. Now see, students, I'm discussing in the case of aqueous zinc sulfate. Suppose aqueous zinc sulfate I'm taking. Now example 1. Example 1. What I'm taking? Aqueous zinc sulfate solution I am taking. Now in aqueous zinc sulfate, which ions are there, students? We know that zinc sulfate dissociates into Zn plus 2 plus SO4 minus 2. This is the cation, this is the anion. And aqueous, I told you, means water dissociates into H plus and OH minus ion. Now see, students, here 2 cations, so 2 anions are there. Now see here, this is the water ion, this is the zinc Zn plus 2 at cations, at cathode. Are you following? So at cathode, now which are there, students? Which are there? Cations moves towards the cathode kada. So these are cations, these are moving towards the cathode. So that's why Zn plus 2 and water I am taking instead of H plus. Okay, na? So water I am taking. Now Zn plus 2 water. See here, at cathode which reaction is taking place, students? Reduction. So reduction potential you have to see. Reduction potential. Reduction reaction, reduction potential will be there. So in case of reduction potential of water and Zn plus 2, which one is more? Now see, Tana, Zn plus 2 and water. See here, Zn plus 2 and water. Now I am taking the second case. So here Zn plus 2 is there. See here I explained you example Zn plus 2 and water. Now which one is more, students? Zn plus 2, water. Now which reduction potential is more? Reduction potential of water, if it is less, then in these two, which one is more, students? Reduction potential of water is less. Are you following? It is less than this electrode potential, this reduction reduction potential. Are you following? So water reduction potential is less than Zn plus 2. Correct or not? This 2. So that's why Zn plus 2, water does not undergo reduction. So which is undergoing reduction? Zn plus 2 undergoes reduction. So that's why Zn plus 2 produces which one? Zinc metal. That's why at cathode, which one is deposited? Zinc is deposited. Are you following? So at cathode, okay, here we know that water electrode, water reduction potential is less than less than Zn plus 2. Clear this one? So that's why what will happen, students? Here Zn plus 2 undergoes reduction. So that's why it undergoes reduction kada. So that's why which metal is deposited? Zinc is deposited. Are you following? Zinc is deposited at the cathode. Are you following? It is deposited at the cathode, students. Clear this one? Now see, students, here at anode which is deposited. Now at cathode completed. Now I am going to discuss about the anode. Now see, at anode which ions are there? Sulfate to OH minus ion. So at anode which ions are there, students? SO4 minus 2, and the one is OH minus ion from water. So I am taking these two. So which this anode, which reaction is taking place at anode? Oxidation reaction taking place. That means which potential will be there? Oxidation potential we have to check. Oxidation potential. Now oxidation potential of water and sulfate ion, which one is more? Sulfate ion and water. Now see, students, here I told you oxidation potential of water and sulfate ion, which one is more? Water is more. Okay na? So water is more, then water only undergoes oxidation, produces which one is liberated, students, at anode? O2 is liberated. Sulfate ion it does not undergoes oxidation, students. Okay na? So only water it undergoes the oxidation, students. Are you clear? Water oxidation potential is greater than sulfate ion. So that's why here water undergoes oxidation. Which gas is released? O2 is released. Are you following? That means O2 product is deposited at the O2 product is deposited. Now see, students, so these two are anions kada. So here at anode we know that oxidation reaction taking place, oxidation potential will be there. So if you see the oxidation potential of water and SO4 minus 2, water oxidation potential is more. So that's why water undergoes oxidation. Are you following? So here water oxidation potential is greater than SO4 minus 2 oxidation potential. So that's why water undergoes oxidation. Are you following? Water undergoes oxidation, students. So that's why which gas is liberated here at anode, students? O2 gas is formed. Are you following? It is liberated at the anode. Are you following? So like this you have to see. So in aqueous zinc sulfate, okay, aqueous zinc sulfate solution if you take, at cathode which one is deposited? Zinc is deposited. Are you following? So at cathode anode. So which one deposited, students? At cathode zinc is deposited, at anode O2 is deposited. Are you following? So at cathode zinc is deposited, at anode O2 is deposited. Understanding, students? So like this you have to find none. Okay, one more example. See, students, I am taking the aqueous silver chloride solution. Okay, second example nana. See here. Second example, aqueous silver chloride. Now tell me, students, aqueous silver chloride. Here aqueous silver chloride is dissociates into Ag plus and Cl minus ion. Correct? Ag plus and Cl minus ion. Water. Okay, another one is water. At the cathode and anode you have to take. This is the cation. Okay, now water dissociates into H plus and OH minus ion. This is the cations. So these cations are moves towards the cathode. So at cathode reduction taking place, at cathode reduction, in reduction what will be the reduction potential will be there? Reduction potential of water and Ag plus. Reduction potential of water and reduction potential potential of Ag plus. Now you check students which one is more. Potential of water and Ag plus. Water and Ag plus. Now see in the second case here, second point, water Ag plus. Water is having the reduction potential is less than Ag plus. So that's why Ag plus undergoes oxidation. Sorry, Ag plus undergoes reduction, produces Ag. Are you following? So which one is less, students here? Reduction potential of Ag plus. Water is less than reduction potential of Ag plus. So that's why Ag plus undergoes reduction. Ag plus undergoes reduction. Now which one is deposited? Ag is deposited at the cathode. Are you following? This is at the cathode, students. Okay, at cathode. Understanding? Now I am taking at the anode. So what is happening at anode? Which ions anode? These ions are moves towards the anode side. That means Cl minus, so water. OH minus ion from water, no? So that's a water only you have to take. Cl minus ion of water. Now see students, these anions are moving towards the anode. So at the anode, which reaction taking place? Oxidation reaction. So that's a which potential? Oxidation potential. So oxidation potential of Cl minus, so oxidation potential of water, which one is more? Now just you check it, students. Here oxidation potential of water and Cl minus. Water and Cl minus here there. Water oxidation potential is less than Cl minus, correct? So less than Cl minus. So oxidation potential of Cl minus, water is less than Cl minus. So that's why chlorine ion oxidation potential is more. So that's why water does not undergo oxidation. Are you following? Does not undergo oxidation. Only Cl minus undergoes oxidation. Are you clear, students? It undergoes oxidation. So that's a Cl minus ion undergoes oxidation. By loss of electron, it becomes half Cl2, correct? By loss of, that means which gas is liberated? Cl2 gas is liberated. Are you following? At the where? At the anode. Okay, Nama. So at anode, are you clear this one? At anode, Cl2 gas is liberated, students. Are you clear? Okay. So I hope you like this video, students. If you like this video, please like, share, comment, and subscribe my channel, Nana. Okay. Thank you very much, students.